1 charge tape for Physics 2212. I'm Hudson Groover. So in Lab 1, we demonstrated electric force through the use of two pieces of tape that we found to be positively charged. Using a repulsion between the two pieces of tape, we were able to find the force exerted on each other, which we were then able to use to find the deficiency of electrons on the tape. So in Lab 1, we also developed a model in GlowScript to demonstrate, visualize, and help calculate the values. So in this lab, we charge two tapes by placing them on another tape and pulling them off. And the physical interaction of pulling it off and lost electrons from the top tape to the bottom tape. And we did that twice in order to make two positively charged tapes. And so then we strung tape B across two books and brought tape A to it until it hovered, and we measured that distance. So in this, our system was tape B and our surroundings was tape A. And so the results of this was the magnitude of the electric force on the floating tape was 9.e to the negative 5 newtons, and the tapes were positively charged, and the point charge of the tapes were 4.38 e to the negative 9 coulombs, and the electrons lost was 2.739 e to the 10th electrons. So for this lab, we made a few assumptions. We assume we are ignoring air resistance on a moving object. We're treating a long tape as though a point charge, all the charge concentrated at the center of the long tape. And we also assume that each U-tape made had the same amount of charge evenly distributed along the length of the tape. Because they could have been different because it's two different tapes that we created, and there's different speeds that you yank them apart and everything in its composition. So in order to do this lab, we had some concepts and measurements for calculations. So we measured that length of the tape was 10 centimeters, so mass of one of the piece of tape was 0.1 grams or 0.0001 kilograms, and the distance between two tapes was approximately 0.042 centimeters. Thus, the force of gravity equals negative 9.8 times 0.001. And so then for some calculations, the force of electricity is equal to force of gravity because it is hovering, so the net force must be 0, and those are the only two forces we're assuming are acting on it. And then the force of electric field, which we will use, is Q raised to the 2 times K over D squared. And electron deficiency equals charge of tape over the charge of a proton or electron magnitude. And then total atoms equals tape area over atom area. So for the procedure, we proved that the upper tape was positive by bringing a charged pencil from rubbing it with cloth, so negatively charged pencil, towards it, and it pulled to it. So that means it's negatively charged positively charged because the pencil was negatively charged, and opposite forces attract. And then we strung the tape between two books and then brought the tape to it and saw that it hovered and measured that distance. So create a force diagram, and then using the equations, plugged in our values to find that it was 4.38 e to the negative 9 was the charge of the tape, and using that we divided it by the charge of an electron to find that 2.739 electrons to the 10th were lost. And so converting this math to code can be seen here, where we put down our constants. We adjusted the scene in order to make everything show and create our objects, and use the function from lab 0 and printed everything. And so the simulation shows this, with the blue arrow being the electric force, red being gravity, and they're equal in the electric charge and electrons lost. And so there was potential errors in this lab because we ignored air resistance, we treated tape as a point particle, and there was probably loss of charge during procedure from handling air and humidity. And measurements were difficult due to the equipment and being a solo tester. And so what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? Well, since protons and electrons are equal in magnitude but opposite, but they also behave similarly, but just in opposite ways. If you switch it, there would be no difference, because if it was negatively charged and you bring in another negatively charged tape, they would still repel. And why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hand or other objects? Because our hands have water and salt on it that can interact with the tape and actually neutralize its charge.